Hello, my pre-calculus student. In this video, we are going to learn how to graph cotangent function of the form f of x equal a cotangent of bx, where a and b are real numbers. Let's review what is a vertical asymptote. It is a vertical line that the graph approach but does not intersect. So here we are. This is the graph of cotangent function, and the function for this basic or this parent function is f of x equal cotangent of x, where a and b they both equal 1. So the first thing we have to notice from this graph is that we see that there are more than one periods of the graph. And so I'm just looking at one period only. Now the y-axis is also the vertical asymptote. So if you look at here, this is also your vertical asymptote. So let's list it right here. In one period, yes. So there are two vertical asymptotes for each period. So I'm looking at the period is pi, the interval from 0 to pi, so that will be x equals 0 and x equal pi. And of course the second period on the left hand side be x equal negative pi, and then they share x equals 0 at the vertical asymptote. So I'm just looking at one period only. Next, now we are going to go ahead and make a table to find cotangent. So let's make a note for ourselves that cotangent of theta is x over y. Okay. Or so I'm going to make a note right here. Cotangent of any angle theta is x over y, or cosine of theta divided by sine of theta. So if you look at the points where the terminal side intersect with the circle, at each point it gives you two values, x and y. X is cosine of that angle, so cosine of 45 degrees will be square root of 2 over 2. And sine of 45 degrees is also the same number, square root of 2 over 2. So let's start with positive angle. So I'm going to counterclockwise from 0. So x is 0. Cotangent of 0 is x divided by y. So 1 divided by 0 is be undefined. So you can see whenever your function is undefined, that x value will be your vertical asymptote. So we have the first vertical asymptote, which is x equals 0. So this will be x equals 0. Next, we are going to go and look for. So you're welcome to try with each one, but each one of the angle. But I'm gonna go fast and quick. So the next one I'm looking at pi over 2. So cotangent. So I run out of space. I'm going to write right here. Cotangent of pi over 2 or 90 degrees. Again, x divided by y, so 0 divided by 1 will equal 0. So cotangent of pi over 2 will be 0. So when plot the points pi over 2, 0. Now you can go back and you can try. Okay, what happened? Can I try with pi over 4? Yes, you're welcome to try with pi over 4. So if I substitute x for pi over 4, then I'm going to do cotangent of pi over 4, cotangent of pi over 4, which is 45 degrees. You see that your x and your y will be exactly the same number. Square root of 2 over 2, divide by itself. Then the answer will be, or the quotient will be 1. So the point will be pi over 4, which is right here. This is pi over 4. X is pi over 4, and y is 1. And then you can move on to, I'm just going to look at the green color, which is multiple of pi over 4. So I'm going to move on to the second quadrant. I'm looking at 3 pi over 4. Again, x divided by y, exactly the same number, except 1 is negative. So x is negative. So my answer will be negative 1. So 3 pi over 4 will be right here. And my cotangent will be negative 1. Again, you can see that there are 3 basic number over here. So negative, 1, 0, negative 1. And lastly, let's look at pi or 180 degrees. So cotangent of pi, again, is x divided by y. Negative 1 divided by 0 will be undefined. That's because we cannot have 0 in our denominator. So every time that your output y value is undefined, that x value will be your vertical asymptote. So again, we will have the second vertical asymptote be x equal pi. So you can see right here that again, for one period, there are 3 basic points where the y value will be 1, 0, negative 1. So the 2 consecutive vertical asymptote will be x equals 0, x equals pi, and the period, the length, but the length for that one complete graph pattern will be pi. So you can repeat on the left hand side. So again, the period is pi, so it will be from 0 to negative pi, and you have your vertical asymptote, and you plus your 3 basic points where the y value just repeats itself. So y equal 1 for negative 3 pi over 4, y equals 0, so negative pi over 2, and y equal negative 1 for negative pi over 4. So you can see, so this could be the second period. Now let's write down the observation. From this graph, we can see the domain. Now you can look at here that I graphed 2 periods. So now I'm going to say that my domain will be all real number on the x-axis except negative pi, 0, and positive pi. If I just look at these 2 periods only, if you talk in general, you can say that I'm going to go ahead and use the set builder notation. The domain will be the collection or the set of all the number x such that x cannot be multiple of pi. So n times pi, where n belongs or n is an element of the set of integers. It means n will be negative 1, negative 2, or 0, 1, 2. Okay. Let's move on to the range. The range, you can see right here that the range, the graph, it just stay from the y value of the graph, it just stay from negative infinity to positive infinity. So I'm going to say the range You're welcome to, I'm going to use the set builder this time, so the collection of all the y values such that negative infinity is less than y is less than positive infinity. Or you can use the interval notation. Let's move on to the x-intercept. Here, look at these two periods. We can see that the x-intercept will be pi over 2, negative pi over 2. So in general, you can say that the x-intercept will be the collection of all the number x such that x equal pi over 2 plus n pi, where n is the element of the set of integer. Now, if it looks very complicated for you, and if you just say the x-intercept are negative pi over 2 and pi over 2 for the domain from negative pi to pi, that should be okay. The y-intercept, we don't have it. Now let's move on to the vertical asymptote. So we know that for each period there are two consecutive vertical asymptotes where the period is pi. So if I look at one period only, my vertical asymptote will be x equals 0 and x equals pi. Now if I'm talking in general, my vertical asymptote will be a multiple of pi. So x equals n times pi, where n belong or n is an element of the set of integer. Symmetry. Symmetry is the point 0, 0. So therefore we can conclude that the function f of x equal cotangent of x is odd function. Okay, now next we are going to learn to graph the cotangent function where a and b they are not 1. I need you to write these 5 steps. If you compare these 5 steps with the 5 steps that we learned from video number 27, for graphing tangent function, they almost exactly the same except step 2. So here we are. To the first step, we are going to determine the period. Again, we assume that b is a positive number. So we'll take pi divided by b, and then we find the two adjacent vertical asymptotes by solving for x for these two equations, bx equals 0 and bx equals pi, and then we divide the interval that formed by our two adjacent vertical asymptotes into 4 equal parts. We make table from the step 3, and then step 5 we just go ahead and connect the points with a smooth curve and make sure that our graph has to stay inside the two vertical asymptotes. So go ahead and write down the first step, and then we will begin to graph the cotangent function where a and b, they are not 1. Okay, so now we are going to graph the function f of x equal 3 cotangent of 2x. Step 1, we unify the period, which is the length between the two adjacent vertical asymptotes, will be pi divided by b, so this will be pi divided by 2. And then step 2, we unify the two vertical asymptotes. So by solve for x for these two equations, 2x equals 0 and 2x equal pi, we solve for x. 2x. Then the first equation, we divide both sides by 2, so 0 divided by 2 is still 0, x equals 0. The second equation be x equals pi over 2. So step 3. So now we are going to divide the interval from 0 to pi over 2 into 4 equal parts. So think about the number line. And again, we do not include the two endpoints. So think about pi over 2 divided to 4. So 4 times we multiply 4 with the denominator, so give me pi over 8. And then the next one will be 2 pi over 8. And then 3 pi over 8. So you can put it in your graph of you. This is 0. This is pi over 8. 2 pi over 8. 3 pi over 8. So 2 pi over 8, and then 3 pi over 8, and lastly will be pi over 2. And let's go ahead and sketch the two vertical asymptotes. The first one be x equals 0. So in this case, I'm going to highlight my vertical asymptote. And the second vertical asymptote will be x equals pi over 2. So this is x equals 0, x equals pi over 2. Step 4, we're going to make a table. So our table will have the 5 values. From step 3, so x 0, pi over 8, 2 pi over 8. Of course, you can reduce the 2 pi over 8 become pi over 4, 3 pi over 8, and then pi over 2. And again, we will start from the innermost, which we will multiply 2 to x. So that will give us 0. And when you multiply 2 to x, you will see that your left end and your right end it becomes 0 and pi. So basically it becomes the value of your parent function of cotangent. So here this will be pi over 2, and this will be pi over 4, and 3 pi over 4. And next step, you want to find cotangent of that, not pi, cotangent of 2x. So again, we know that the cotangent of 0 is undefined. Cotangent of pi over 4 will be 1. Cotangent of pi over 2 will be 0. 3 pi over 4, negative 1. And pi be undefined. Undefined this. And last step, we will multiply 3 with the 3 middle value right here. So 3 cotangent of 2x. So that will give it 3, 0, negative 3. And the 2 asymptotes still undefined. So now step 5, we will plot the points. So step 5, we will plot 3 points. So the first point will be pi over 8, comma 3. The second point will be 2 pi over 8, comma 0. And the third point will be 3 pi over 8, comma negative 3. Okay, so pi over 8, comma 3, so 1, 2, 3. 2 pi over 8, comma 0. 3 pi over 8, comma negative 3, so 1, 2, 3. So now after you get the 3 points, you need to connect the points with the curve and make sure that your graph doesn't intersect with the asymptote. So just to get closer, so I have to make sure I erase this. Sorry, my graph doesn't look good. So let me try to make it look beautiful. Here we are. Look okay, not bad at all. Okay. So this is the graph of the function f of x equals 3 cotangent of 2x. Of course, you can graph additional periods, but I just only graph one period. So make sure write out the summary at the end. So let's write out the summary now, dear. Summary. In this video, we learned this. How to graph cotangent function. F of x equal a cotangent of bx. Thank you so much for watching this video. I will see you in class. Goodbye.